Welcome to the third video in the Level 3 Electrical Design Cable Selection series from the Focus Training Group. Today we're going to take a look at rating factors. Rating factors, which may formerly have been referred to as correction factors, are multipliers we're going to use to help determine the current carrying capacity of our circuit conductors in our circuit design. Section 523 of BS 7671 tells us that circuit conductors should be selected so they're able to carry the current demand of the circuit without exceeding the particular cable's temperature limits. To meet these regulations, we need to take into account rating factors. Essentially, rating factors are multipliers that take into account the circuit conductor's ability to dissipate heat due to external factors. Remember, one of the main purposes of our circuit design is that we are able to select a circuit conductor that can carry the required design current without that conductor rising to a dangerous temperature, therefore causing danger to itself and any of its surrounding materials. Appendix 4 of BS 7671 gives us the various rating factors that could affect our circuit design, and they're identified as follows. CA is for ambient temperature, CC is for circuits buried in the ground, CD is for depth of burial, CF is for overcurrent protective device factor, CG is for grouping, CI is for thermal insulation, and CS is for the thermal resistivity of soil. The factors for ambient temperature can be found in BS 7671 tables 4B1 and 4B2, contained within Appendix 4. 4B1 gives rating factors for ambient air temperatures. 4B2 gives rating factors for ambient ground temperatures. As we can see on the slide here, we have a snippet of table 4B1, which is the rating factors for ambient air temperatures other than 30 degrees Celsius. And how we interpret this table is as follows. In the left-hand column, we can see the ambient temperatures in degrees Celsius. The snippet we have shows 25 degrees, 30 degrees, 35 degrees, and 40 degrees. Along the top row, we can see also that we have our different types of insulation for our conductors, looking at 60 degree thermosetting, 70 degree thermoplastic, 90 degree thermosetting, and then 70 degree and 105 degrees for mineral. How we interpret this table is as follows. If we look at the ambient temperature on the left hand side and then go along to our selected insulation of our conductor, we can see a number, and this will be our rating factor that we use later on in our calculation. So for example, if we looked at the ambient temperature of 40 degrees Celsius and the insulation of 90 degree thermosetting, we can see our rating factor would be 0.91. The rating factors CC, CD and CS cover the rating factors for cables buried in the ground. For CC, we have to take into account the current carrying capacity tables in BS 7671 are based on ambient ground temperatures of 20 degrees Celsius. To account for the rise in temperature under overload conditions, Regulation 433.1.203 gives a factor of 0.9 to be applied to all buried circuits. Table 4B3 in Appendix 4 of BS 7671 gives us rating factors for where the thermal resistivity of the soil is known. This is our CS rating factor. Where the thermal resistivity of the soil cannot be determined, the rating factor 0.9 should be applied. The example we have on this slide is for the rating factor CD, and this is where we have our cables which are laid at a depth greater than 700 mm. The required current carrying capacity in these circumstances will increase. As we can see on the table, we have the depth of laying in meters going down the left hand side in the left hand column, and then we have two other columns, one for buried direct and one for in buried ducts, which gives us our rating factors for these two different situations. So for example, if we were to look at the left hand column and say we had our cable buried at a depth of 2 meters, if it was buried direct, therefore not inside a duct, you can see the rating factor would be 0.92. If it was, however, contained within a duct, our rating factor would be 0.93. CF is the overcurrent protective device factor and is given in relation to the fusing factor of the device. Regulation 433.1.1 indent 3 states the current causing effective operation of the protected device, otherwise known as I2, does not exceed 1.45 times the lowest of the current carrying capacities, IZ, of any of the conductors of the circuit. Most modern protective devices activate at or below 1.45 times IN, meaning that I2 is less than or equal to this value. Therefore, the CF factor usually equals 1. When the protective device does not meet this criteria, the following calculation applies. We have CF, our rating factor, will equal 1.45 times the rating of our protected device, IN, divided by the current causing operation of that device, I2. The most commonly used example of this is for semi-enclosed fuses to BS3036, or otherwise known as rewirable fuses. It is widely known that the current causing activation of these devices, I2, is assumed to be twice that of the rated current, IN. So if we use that formula, we come out with 0.725 for these devices, and that figure is also given in BS 7671, Regulation 433.1.202. CG is the grouping factor, and it's given in tables 4C1 to 4C6 of BS 7671. There are many things to consider when choosing the correct grouping factor, such as the loading of each circuit and the way in which they are grouped. The most commonly used table is 4C1. The snippet on our slide here shows us table 4C1, and it's the rating factors for one circuit or one multi-core cable, or for a group of circuits, a group of multi-core cables, to be used with current carrying capacities of tables 4D1A to 4J4A. We can see in the second column we have our arrangement, so whether our cables are bunched in air on a surface embedded or enclosed, a single layer on a wall or floor, single layer multi-core on perforated horizontal or vertical cable tray systems, and single layer multi-core on cable ladder systems or cleats. Then across the top row we have our number of circuits or multi-core cables, and in the final column says which of the reference methods should be used with our current carrying capacity tables. So for example, if we were to look at item number 2, the single layer on wall or floor, so we had a single layer of conductors, maybe clipped direct to a surface, and we have our number of circuits or multi-core cables. If we just had one, that would just be our circuit, so that would be a rating factor of 1. If we had 4 circuits, that would include our circuit and 3 others. We can see that for the single layer on a wall or floor, our rating factor would be 0.75. CI is the factor for cables run through thermal insulation. It should be noted that this factor only applies where cables are totally surrounded by thermal insulation and not just rested on. Where a cable is totally surrounded by thermal insulation for more than 0.5 meters, the current carrying capacity should be taken as half the capacity stated for that cable clipped direct. Where the cable runs through thermal insulation for less than 0.5 meters, Table 52.2 of BS 7671 can be referred to for limited conductor sizes and thermal resistivity rating of the insulation. Those ratings are given within that table. If we take a look at the snippet of the table here, we can see we have 2 columns, one for the length in insulation in millimeters, and one for the corresponding rating factor to be applied. So for example, if we had our cable running through 100 millimeters of thermal insulation, then our rating factor would be 0.78. We hope you've enjoyed this video. Join us next time when we'll use the information from the first 3 videos to put into the calculation to help us select the size of our circuit conductor.